My name is Ernest, and this is Ernest Sciences and Mathematics TV channel. I'd like to welcome all our members to our discussion for today. And we're going to look at the concept of momentum and impulse and try to find the relationship between the two concepts and Newton's second law of motion, or how we can represent perhaps one in terms of the other. And we're going to use this specific type of Newton's second law of motion, which we have discussed in one way or another in our previous videos, and try to see how we can basically try to represent them in terms of the other server said. And this is going to be finding a wide range of applications, especially in our day-to-day life, especially on different, of course, events that we're going to come across, especially concerning the concept of collisions and, of course, the concept of explosions. Now, if I may give an example of this specific, of course, events which I've mentioned, we're going to come across this specific aspect of collisions, especially and our study of gas laws, whereby I've mentioned that for us to describe the pressure of a gas, we're going to have it as this specific aspect of particles which are going to be bombarding, of course, the surface of the container. And from the kinetic molecular theory of gases, we have already looked at this specific concept, of course, which is going to be assisting us in trying to do an analysis of this specific case. Now, in a sense, this aspect of momentum is going to be handy for us in trying to describe these specific events. And of course, we're going to see that we can find the concept of motion of, or describe the motion of a rocket using the gases which are going to be ejected, which of course is going to be a combination of its mass and the velocity of gases which are going to be ejected from this specific rocket. Now, in this case, we're going to see that this aspect of momentum is going to be assisting us in trying to describe these specific events, and therefore this is going to be some of the applications which we are going to see from this specific relationship of the three ideas which I've just mentioned. Now, we're going to start this one from the concept of Newton's second law of motion, and that is going to give us a basis for us in trying to describe these other aspects of perhaps momentum and impulse. Now, from Newton's second law of motion, we're going to have this one aspect of a force given in terms of the product of mass and acceleration. And we can give this one in terms of a representation, whereby we're going to have force represented as a product of mass and acceleration given as that. But we say that in this specific case, we can have acceleration given in terms of the change in velocity all over time given as that one. And therefore, we're going to have this representation of the second law, Newton's second law of motion, given in terms of a force is equivalent to mass and change in velocity all over time, given as that one. If we multiply both sides by a time of this specific equation, we can have a form of the equation given in terms of Ft is equivalent to m into v minus u. And therefore, that's going to be forming what we refer to as the product of a force times time, which is going to be on our right side of this specific side of the left part of this specific equation. And therefore, this force times time is going to be giving us what we refer to as impulse. And therefore, let me just have it this way. So, and therefore, we're going to see that this specific concept of the product of a force times time for a specific particle of a mass m and traveling at an initial velocity of v and, of course, initial velocity of u and the final v, we can equate the product of time and, of course, force as an element of impulse in trying to describe this specific change in momentum given as such. So, therefore, we can define impulse as a product of force and time. And if a force, this specific force which we have just given in this particular case, we're going to see that the moment or the, of course, time interval within which this aspect of impulse is going to occur is relatively shorter. So for us to have this specific actual force represented, and therefore we're going to take an average, since the actual force that is involved is going to be varying with this time interval that is under consideration. Now, in this case, we're going to see that basically the units of this product of a force times time is basically going to be given as a newtons per second and of newtons second. And in this case, this is not going to be having a special name as other units which we have been coming across. So this is going to be pertaining the concept of impulse. Now, if we may try to look at the concept of a momentum, we had basically defined momentum as a product of a mass of an object times its velocity. And in this case, if we are going to consider an object of a mass m and the velocity v, we can define this specific aspect of a momentum. And therefore, this is going to be also having a specific representation, whereby if we consider this a specific momentum, and then it's going to be given. So we're going to come across various texts which we're going to be having to represent this aspect of a momentum, whereby it's going to be given as of course, a product of mass times velocity. Now, the of course, units which are going to be used for this one is kilograms meters per second, which are going to be the respective units for mass and the velocity are given as such. So in this case, we're going to see that there is going to be a particular relationship between the two units which you have mentioned for impulse and momentum. And of course, that's going to be true for subsequent videos, which you are going to look at deeper details of those specific concepts. Now, suppose we consider an object which have said of a mass m, mass of object given in terms of m. And if this object is traveling at, of course, a velocity initial, or its initial velocity is given in terms of u, and perhaps a velocity final can be described in terms of a v. And we consider that this object is going to be described using its velocity and mass component. Then we can give its initial, of course, momentum using mu, and this is going to depict its initial momentum. Now, respectively, we can have its final momentum given in terms of this specific representation of mv given as that one. So if we consider this one, we are described from the concept of this specific impulse, the aspect of a change in momentum, whereby if we give this impulse, this is going to be given in terms of mv minus mu given as that, whereby we have defined mv and u from this specific three aspects which I've just mentioned in my previous statement. Therefore, we can give this a second aspect of the equation in terms of change in momentum, whereby we are going to consider that is if this specific force which is going to be applied, of course, on this particular particle is going to be changing the aspect of momentum within a time interval. So let's have this time interval for this specific, of course, particle applied, for this specific force of F applied on a particle with a time interval of delta t. We can have a version of this specific equation regarding the change in momentum given in terms of this representation, which is given as F delta t is equivalent to, of course, this specific mv, and we're going to have this one as a delta m given as that one to imply the change in momentum. So this basically is going to be giving us a relationship between this impulse and the change in momentum, whereby we are going to have this specific aspect of impulse basically defined as a change in momentum, thereby creating the relationship which I had mentioned earlier for this specific case. Remember, this was a development from Newton's second law of motion, and we can see the relationship between the three having an interplay, which we have just been mentioning on the board. Now we can do a rearrangement of this specific equation which we have given above, and it's going to be giving us, if we take f as a subject of this specific formula, we're going to have the delta mv all over delta t, giving us this specific aspect of the resultant force acting on an object, which can be described in terms of its rate of change of momentum given as delta mv over delta t. And therefore, this is going to be forming another version on an alternative form of Newton's second law of motion, which we had given in terms of m is equivalent to f is equivalent to ma. And if I may challenge us in this specific case, we're going to have if a mass of this, we said that mass is an intrinsic property of this specific particle. So if we consider it to be a constant value, we're going to have it as m delta v all over delta t. And the second aspect of this specific equation, which is going to be equivalent basically to this section of the equation on the right side is equivalent to acceleration. So in this case, this is still going to be having a relationship between that one and the Newton's second law of motion. And that is why basically I've said that this specific form of representation for this force is basically an alternative form of a Newton's second law of motion. And we are going to see that this specific change of momentum is going to occur in the same direction as the resultant force which we have just mentioned. And for that specific respect, we're going to see that the force and the momentum are going to be vector quantities as I mentioned from some of my previous videos. Now, in this case, this is going to be one of the analysis which we are going to come across, especially having an interplay between a number of our concepts. But I hope that we have appreciated the development from Newton's second law of motion, which is going to be giving us some of the aspects of this particular, of course, events which we have seen describing perhaps, or which are going to assist us understand deeper and better into some of the events like collisions and explosions, which I had given as an example of some of the application in rockets or spaceships, and some of the, of course, aspect which we had just given as describing the kinetic molecular theory of gas in terms of pressure. So that is it for now, guys. Kindly check out description boxes for various links of other videos. Engage us in the comment section and also ring that notification bell for various updates on different subjects in math and sciences. So that is it for now, guys. Bye, God bless you. Catch us in our next video.